Chapter 7, lessons 7 and 8. We're going to go ahead and cover 2 lessons today because lesson 7 is pretty simple. Okay, so then we're just going to go ahead and knock out lesson 8 too. You're going to have a quiz Thursday. All right, so this way we can have 2 days of practice over it because lesson 8 is not hard, it's just different. Okay, not difficult, it's just different. It just looks funny. Okay, so it'll take your brain a little while to kind of, Kate, turn around and stop talking. It'll take your brain a little while to kind of figure out what it's talking about, but it's really not super difficult. All right, so lesson 7. Lesson 7 is, so y'all remember when we learned how to do special products? Like a sum times a difference? Or squaring a binomial?
Yes.
Okay, you remember squaring a binomial. So sometimes the difference was like x plus 8 times x minus 8. They're the exact same thing except one's a plus and one's a minus. Okay? So did we have to go through every single step to do those? What was the shortcut?
First times first, last times last.
First times first and last times last. So x times x is
X squared.
positive 8 times negative 8.
Negative 64.
So this was one of the only times that it did not give us a trinomial, right? It gives us a binomial, just 2 parts, correct? Well, now we're going to learn how to go backwards from that, which obviously is pretty simple, isn't it?
Yes.
If you see a binomial, all right, the first thing that you should think of is, ooh, maybe this is a difference of 2 squares, all right? The reason we call it a difference of 2 squares is because difference means to do what?
Subtract.
So there should be a subtraction sign. And 2 squares would mean 2 perfect squares. Is x squared technically a perfect square?
Yes.
Yeah, because it's got a square on it. Is 64 a perfect square?
No. Yes.
Yes. What is the square root of 64?
8.
8.
Why did I say X?
Remember, a perfect square is any number that is found by multiplying 2 of the same numbers. So 8 times 8 would make 64. So 64 is a perfect square, and the square root of that is 8. Is 81 a perfect square?
Yes.
Yeah, 9 times 9, right? Is 4 a perfect square?
Yes.
Is 1 a perfect square?
No.
Yeah.
Yes.
1 times 1 is 1. Is 0 a perfect square?
Yes.
Yes. 0 times
Don't
0
come to
is...
But that's not a square, that's just nothing.
Yeah, but still, if you can get 2,
With the
if you
number
can multiply
equivalent to
2
0.
numbers, 2 of the same numbers to get it, then it's a perfect square. 0 times 0 is 0. Okay? 169.
Yeah, I don't know. Probably.
It is.
I taught y'all these last year, so
15. Is it?
13.
Good try, man.
I don't know.
225 would be 15.
Oh yeah, I remember when you made us memorize it, and it was like 20 seconds, then 50 seconds, like a minute or whatever.
Mhm.
Yeah, we
That
did
last
that
year.
Glad to know you still know them.
I
Okay.
don't know them.
So,
I don't.
anyway, moving on. All right. So here, if we're going to go backwards, so now I'm going to give you the binomial, all right? And then you have to determine if it is a difference of 2 squares. So let's say I've got x squared minus 121.
Yes.
Is that a difference of 2 squares?
Yeah.
Is there a difference sign,
Yes.
which is a subtraction sign? Yes. Are there 2 perfect squares?
Uh-huh.
Yes. So a difference of 2 squares is going to factor into 2 parentheses, just like normal. And it's always going to factor into what we call a sum times a difference. Sum means plus, difference means minus. So a difference of 2 squares factors into a sum times a difference. Okay? Then we just take the square root of each. X squared is the first number, right? Well, what is the square root of x squared?
X.
So x goes in the first part of each. Remember, to take the square root of something, you ask yourself, what times itself makes x squared? X times x makes x squared, right? So because that's at the beginning, it goes at the beginning of both parentheses. What's the square root of 121?
11.
So since it's at the end, it goes at the end of both parentheses. And that's our answer.
Oh,
Wait, that's all?
That's it.
Are you gonna add another step to make it harder?
Yeah.
Not, well, I mean,
Yes.
kind of, but it's
Yeah.
not
How do
really.
you
Do
always
that.
have to make them harder? You just make them all easy, but like,
So again, that's called a difference of two squares,
Oh, you're
which factors into a sum times a difference. I'm actually gonna write that out. A difference of two squares equals a sum times a difference. So maybe out here I'll put x squared minus 49, and down here x plus 7, x minus 7. That way you've got a small example to kind of go with it. Okay, we ready? Good. All right. Let's
Wait,
do.
Miss Vin,
Yes.
is today like full out casual or BCA casual?
No idea.
Yeah.
I don't want y'all to do this one by yourself. Y'all should be done.
What? I just wrote it down.
Not that hard.
Well,
Okay.
All right, what's the answer, Kate?
x plus 5, x minus 5.
M plus 5
Oh,
and M minus 5, which is fine for the quiz, but on Schoology it will count it wrong.
Can you just make them all X's?
Every
Too
letter.
late, I already done them all. And it doesn't give me the option, like I literally have to go through and change all of the letters like separately. So, it makes it slightly difficult. Now, let's do one that's slightly,
More. It's gonna be not a perfect.
No,
It'll just be triple.
4n squared minus 1.
Uh,
Now, even though the first number doesn't have a coefficient of 1, we still have to make sure that whatever its coefficient is still a perfect square. So what is the coefficient here? 4.
Oh.
And is 4 a perfect square?
yeah.
Yes. Is 1 a perfect square?
Yeah.
Is this a difference?
No.
No.
Yes.
Yes.
I don't know what
There's still a subtraction sign, guys.
That's a plus
All right.
sign, can't you see?
So, is this still a difference of two squares?
Yes.
Yes, it fits all of the criteria. So it still factors into a what?
A sum.
Sum times a difference. Now, 4n squared is what's at the beginning, right?
Yes.
What's the square root of 4?
2.
What's the square root of n squared?
And
So put the two together and you get
2n.
that's at the beginning. It's not a 2 here and an n here. Because 4n squared is together, its square root has to be together. And then what's the square root of 1?
1.
Wowzers.
Is that the hard part?
Yep.
Sure
is.
Watch her be like,
For a difference of two squares.
How many questions is it on school?
20, I think.
Oh, thank the Lord.
Alright.
Praise
Don't
Him.
celebrate too early.
She's gonna turn into like.
Not an eraser.
And then.
She got like a smile on her face. Like
Yeah,
she knows
like-
it's coming.
Like she's like.
I was laughing because I thought I was erasing.
Sure you were.
And then I just went over it and started drawing.
Convenient excuse.
Alright, work this
She
one.
knows it's coming.
I said this is as hard as it gets for a difference of two squares.
Yeah,
But there's no lesson.
Not the difference of two
Oh
notes.
crap! We have different lessons.
Oh, hold up, just kidding.
Notice, did I ever mention anything about a sum of two squares?
Oh, what? What?
A sum of two squares?
See?
No, did I ever say anything about a sum of two squares?
No.
No, I'm saying something about it now. It doesn't exist.
Oh, okay.
If you see a plus sign there,
Run.
you can't do it.
It just doesn't work like
Oh.
that.
Yeah, you're
For
probably-
squares.
There's gonna be problems like
In algebra 2, you'll learn about cubes, but you'll cross that bridge when you get there.
Can we just bring
Well,
the bridge
you
and not have
won't
to
be
cross
there.
it?
but,
Geometry
you know.
just like
You
in
won't
the
stay
middle.
on this
side of the river.
We won't cross this bridge.
You will cross the bridge just with a different teacher.
I'm gonna burn the
Alright.
bridge.
So you should have an answer here.
Just be like.
What is it, Brayden?
It's 5x plus 4.
4.
5x minus 4.
What you think?
Yeah, yeah,
Very
four.
good.
Don't even. Boys, facts, boys.
Okay, I know now, Rebecca. Don't be a smart.
Whoa!
Hey guys, calm down, please.
We're the one that's-
Nope, stop talking.
We're
Stop
just upset that
talking.
you're leaving, so now we're
Lucy,
leaving.
stop talking.
Nice.
Alright, so that's a difference of two squares. Let me just give you one more.
Okay.
You get like one more.
Well, I thought it was the same problem.
No.
12.
Wait, really?
Yeah, okay. Thanks,
Have you taught us how to do this? Or?
I'm just gonna assume it is 6. Is it 6?
No.
Like, I know it's not
Six
6.
times three.
Yeah, I know, but like if you divide
What
like
is
your
like-
dog.
Is this a difference of two squares?
No.
No, it's not. So does it factor into a sum times a difference?
No.
No. However, what do 12 and 16 have in common?
I don't know. 4.
They're both even, which means they have a GCF, right? Okay, Kate,
You cheated.
calm down. Everyone else, stop talking. In order for it to be a sum times a difference, Kate, a difference of two squares, it has to be two squares. Is 12 a perfect square?
I don't know.
No.
Is there a number you can multiply times itself to give you 12?
Yes.
What?
Oh, no.
No. Okay, because 6 times 6 is 36, right? Not 12. 12 is not a perfect square. 16 is, but 12 is not. Therefore, this is not a difference of two squares. But it does have a GCF, right? So just because it's not a difference of two squares doesn't mean that we can't simplify it. Alright, it is a GCF. It does have a GCF. And what is the GCF in this?
4.
4. So we're going to have to factor out
Oh,
a
crap.
4. Right. So I write a 4 on the outside and then a parentheses. When I'm factoring out a 4, what am I doing? I'm
Dividing.
dividing by that 4. Okay? So what is 12 divided by 4?
3.
So now I've got 3x squared minus, and what's 16 divided by 4?
4.
Did it make a perfect square then?
No.
No. But this would technically be your answer. Okay? So just because it's not a difference of two squares doesn't mean you can't necessarily do anything to it. You should still check for a GCF, a simplifying. Okay? But we're going to do more of those at the end of this lesson.
Like the end of. Is this still lesson 7?
Yes. But that one goes into lesson 8. I just wanted to throw it out there. Alright. Okay, so that was a difference of two squares. Now, do y'all remember the other special case was squaring a binomial, right?
Sure.
I taught y'all how to square a binomial. So, the rules were Okay, you can just write it twice if you want to and do it like normal. Or you can memorize the short rules where you do it in one step, right?
Oh, it's like multiply for.
You square the first. So what is x squared?
X squared.
X squared.
Yeah.
Multiply the 2. So what's x times 4?
4x.
And double.
8x.
Because we would double because it technically would be this parentheses twice, right? So plus 8x. And then square the last. So what's 4 squared?
16.
16. Now,
1.
the way, so now what I'm going to do is I'm basically going to give you this trinomial, and you're going to have to factor it back into a parentheses squared, a binomial squared. Now, just like the other ones had special names, so do these. This is called a perfect
Circle.
trinomial
Yes.
squared.
Alright, down.
Nope, perfect square trinomial. I got those two backwards. Perfect square trinomial. The reason it's a perfect square trinomial is because the first number is a perfect square, the last number is a perfect square, and the middle is found by multiplying and doubling those square roots.
Oh.
Okay?
What?
So what's the square root of x squared?
X.
What's the square root of 16?
4.
The product of that is
4x.
4x.
doubled.
8. Oh.
Alright, so if it meets that criteria, it is a perfect square trinomial. We'll do more problems, it'll make more sense.
That sounds good.
Okay?
It makes sense, but like who
But it doesn't.
Now, if you recognize that, you don't have to go through all of the processes of factoring and writing the words add, same, finding your factors of 16 that add to make 8. If you recognize that this is a perfect square trinomial, then you will automatically be able to say, oh, this will factor into a binomial square. Okay? So again, the way to tell is the first and the last have to be perfect squares. We've already figured out that just because, like that last number is not always a perfect square, is it? We could have the number 24. Is 24 a perfect square?
No.
No. Okay? So this would have to be a perfect square in order for this to be a perfect square trinomial. But not only does it have to be a perfect square trinomial, it has its square roots, so the square root of x squared and the square root of 16, multiplied and doubled, have to make the middle. Alright? So again, the square root of x squared is, the square root of 16 is 4. Those two multiplied makes
4x.
4x, and doubled makes
8x.
8x. Okay? Alright. So to get our answer was basically what we would do now is we would say, what's the square root of x squared?
X.
What's the square root of 16?
4.
What's the middle sign?
Plus.
That's it. So if you recognize it, you just pull it straight down. Now, a lot of you are going to get this and sometimes a difference mixed up because you essentially do the same things to get your answers, right?
I guess.
If it starts out as a trinomial and it's got two perfect squares, your answer will be a binomial squared. If it's a binomial with two perfect squares, your answer is a sum times a difference. You just have to memorize those. All right? That's the only thing that, so like actually doing it is easy, but remembering which one is which is the hard part because you work them very similarly. Similarly. Okay. All right, so let's work some more of these. Oh, I literally just did that one. Is this a difference of two squares?
Mm-hmm.
No.
No.
Is
Is
it,
there a minus sign in there?
no,
Is this a binomial?
no.
No, this is not a difference of two squares. I was trying to trick you. Is this a perfect square trinomial?
Yes.
Yes.
Maybe, right? Is the first number a perfect square, Kate?
Yes.
Is the last number a perfect square? Okay. What is the square root of x squared?
X.
What's the square root of 25? Multiplied?
5x.
Doubled.
10x.
Is that the middle number? So is this a perfect square trinomial?
Yes.
Yes.
Sure.
Okay. What does a perfect square trinomial factor into?
A binomial.
A binomial
Squared.
what? Squared. Okay. And how do I find that answer?
You get
Take the square root of the first, which is
that
square root of the last, which is
5.
middle sign is a
Plus. Ow.
okay.
Weird. I did it.
Questions?
No.
Okay.
Mm.
9x squared plus 12x plus 4.
Two, you just have to put like the three.
Right. So again, we need. Is this a difference of two squares?
No.
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 It was like a half no, half yes there. All right. Is it a perfect square trinomial?
Mm-hmm.
Maybe, right? The reason I keep saying maybe is because we can't just assume because the first two are perfect, the first and last are perfect squares that it is, right? The middle has to work out. Okay, so this is a maybe because the first is a perfect square and the last is a perfect square. So what's the square root of 9?
3.
What's the square root of 4?
2.
What's 3 times 2?
6.
Doubled,
12.
and that's the middle, right?
Yes.
Okay, so it is a perfect square trinomial, right?
Yes.
What does a perfect square trinomial factor into?
Binomial square.
A binomial or parentheses squared, a binomial squared, either one's fine.
Yeah.
Now, what's going to go in the first blank?
3x.
3x, because we had 9x squared, right? So the square root of 9 is 3, and the square root of x squared is x.
So
What's the square root of 4?
2
And what's the middle sign?
plus.
Plus.
So 3x plus 2.
Is this less than 8?
No, still less than 7. All right. Now, what I want you to recognize is a perfect square trinomial always has to have a plus at the end. Okay? Because can we take the square root of a negative number?
No.
No, because nothing times itself ever equals a negative, does it?
Oh no.
2 times 2 is
4.
negative 2 times negative 2 is,
Positive 4.
yeah, you get positive every time, right? The only way to get a negative is to do a positive and a negative. But at that point, are they the same number?
No.
No, so it wouldn't be a perfect square. So if at any time this is negative, it is not a perfect square trinomial. This could be negative, but this cannot be. All right? And let's do one more, and then we'll move on to lesson 8. Are the first and last perfect squares?
Yes.
Yes, so this is maybe a perfect square trinomial, right? Is the last a positive?
Mm-hmm.
Yes, so we're even closer. Now we just have to make sure the middle number matches up.
If it's not, is it a no solution?
You'd have to check for a GCF first, but if there's no GCF or or it doesn't factor, then you would have to try your add, same, and all that stuff. And if it still doesn't work, it wouldn't be no solution, it would be what we call prime.
Just doesn't work, does it?
Yes, it does.
What's the square root of 25?
5,
What's the square root of 4?
2.
What's 5 times
Oh, you
2?
guys double it.
Double. Oh.
10 doubled is
I forgot to.
Negative
20.
20.
Yep. So this is a perfect square trinomial, which factors into a binomial square. What goes in the first spot?
5x.
5x.
What goes in the second spot?
2.
What's the middle sign?
Minus.
Very good.
That's minus.
because we take the middle sign. What'd you say, negative?
Said plus.
Oh,
That's the
Well,
I was trying to give you a chance, but.
That's okay.
Nope.
All right, any questions on those special cases?
No,
If you forget and you don't remember the shortcut, can you do it the long way?
I mean, if you
What's the
Yes.
long way?
What I taught you last week. Add, same, multiply the 25 by the 4 to get 100,
Yeah.
and then factors of 100 that would add to make 20, which would be 10 and 10.
Wait, so the test we just took, we could have done this the whole time?
No.
Yes.
For this one, not for the binomials. Binomials have to be done, the difference of two squares has to be done the way I just showed you. But a trinomial, you can do the way you did last week. Just like when we were multiplying a binomial squared, you could just write it twice and do it the long way, right?
Mhm.
Same way here. You can do it the long way, but if you recognize it, it'll make your life easier. And I would like for you to recognize it because in some of your harder math classes, if you can recognize that and go straight into a binomial squared, that's only one tiny section of a problem. Okay? So if you can do that in a short step, you're more likely to be able to work the rest of your problem
Wait.
more, like a little bit quicker.
Are we making songs on this one?
Not on this one, no.
Which one?
that'd be a boring song.
That's the next chapter.
That'd be a boring song.
When is that gonna be, in May or April?
When we get back from the trip.
Yeah.
All right. Now lesson 8. Okay, so lesson 8.
Get that smile off your face. Stop smiling.
No.
Yeah, this is like evil.
Okay.
Yes, you meant
Don't-
it didn't
don't
get
do
harder in lesson 7, it gets harder in lesson 8.
Yeah.
Really?
A
Doesn't
bunch
it?
of prime numbers and cubes.
Ugh,
Can we just do
Gosh,
that is
dang.
disgusting.
I
Take
think
it
I'm
back.
having a habit.
This is
Because
gross.
Oh, there's more.
I suppose.
All right, so this right here is not a binomial. It is not a
It's a
trinomial.
quadruple
It's a polynomial.
As we just call this a polynomial. Okay, it only has a name for the first, second, third. Monomial, binomial, trinomial. After
What's
that,
a
we just call them
monomial?
polynomials.
One, Andrew, it's one.
Monomials, one.
Like, every-
So, like, all polynomials are made up of monomials.
Wait, I thought bio was
Bi-
Bio,
A little
like
off.
bio.
Bio would be like the study of living things.
Okay, that's not
All right, so moving on,
on.
guys. This is not super difficult, but it's also not the easiest thing in the world. So you're gonna need to pay attention. All right, so when we are given 4 monomials, okay, so when we're given 4 different parts, we have to factor this by a way that we call factor by grouping. Okay, factor by grouping. Now, one of our properties, which property is it? The associative property, I believe,
Sure.
allows us to group things into different orders. Okay? So if I have, basically it's saying if I had 4 plus 6 plus 7 plus 10. Okay? I could group them and do 4 plus 6 and 7 plus 10. So 4 plus 6 is,
10,
7 plus 10 is,
17.
and then 10 plus 17 is 27. I could group them like that, or I could move them around and I could group them in a lot of different ways, right? Either way, it didn't really change the problem, did it? It just changed what order I looked at it in. So we're going to do this the same way as well. We're going to group these, and we're going to do it by grouping the first 2 together and the last 2 together. A plus sign has to be in the middle for this to work. Okay, so I'll do a -1 next so you can see what to do when there is a minus in the middle. But a plus sign has to be in the middle for you to be able to do this. So, we now have 2 binomials, right? The only thing you know about a binomial is the difference of 2 squares. Are either of those differences of 2 squares?
No.
No, what was the giveaway?
There's
No subtraction sign, okay? There's not a subtraction sign, it's very obviously not a difference of 2 squares. But what did I show you at the end of that little section? when it wasn't a difference of two squares, we could still do what? Take out a GCF,
Mhm.
okay? Both of these have a GCF in them. All right, now, sometimes our GCF can be more than just a number. Sometimes they can have variables in common as well. And this is one of those situations.
Is it 4?
Okay, we're just gonna look at each parenthesis separately. So let's look at the first parentheses first. So we're gonna look at our numbers, 7 and 5. Do 7 and 5 have anything in common other than 1?
No.
No. So there's not a number GCF here. But what do both of those numbers technically also have in common?
X.
And X.
They have an X on both of them, don't they? Now, this one's got an X to the third, which literally means there's how many X's?
3.
This one has an X squared, which means there's how many X's?
2.
2. When we're finding a GCF and we're factoring it out, we're taking it out of, we're dividing it, aren't we?
Mhm.
Can I take 3 X's out of 2 X's? No. But can I take 2 out of 3?
No problem.
Yes. So when you're looking at a variable GCF, you always take the one with the smallest exponent. Because you can take small things out of big things, right? So x squared can come out of x squared, right?
Mhm.
And can x squared come out of x to the third?
Mhm.
Yes. So our variable GCF is x squared. Okay, so you need to write that.
Okay.
And it's going to factor a new parentheses out. All right?
Just one.
Just one, because we're only doing one parenthesis at a time.
Right.
Now, if I'm factoring out, I'm doing what operation?
Factoring.
Dividing. So I'm dividing this by x squared and this by x squared. So chapter 6 says that when we're dividing like bases, we do what with the exponents?
Minus.
Subtract them. Are these like bases? 3 minus 2 is
One.
1. So the 7 doesn't go anywhere, right?
No.
Okay? And so then I just have 7x, right? Because it's literally, if I take 2 x's out of 3 x's, I'm going to have
One.
1x left. Plus, the 5's going to stay, right?
Mhm.
2 minus 2 is,
0.
and anything to the 0 power is
Nothing.
1.
Just kidding.
Alright? So, that would make it 5 times 1, which is just 5. So basically, those just canceled out, right? Remember, anything that's not the same on top and bottom cancels out to make the number 1,
Mhm.
and then you multiply that 1 by whatever's left. What if there isn't anything left? Then it's just 1, okay? So that's the first parentheses. Now we're going to do the same thing to the second parentheses, but we're looking at it separately, okay? So we're not taking out the same thing we did in the first one. So I'm going to look at this one. We look at our numbers first. So we've got 56 and 40. Do 56 and 40 have a GCF?
Yes.
They do have a GCF, okay? I know for sure because they're even. So at least 2 goes into both. But there is a bigger number. The greatest common factor is 8. 8 goes into both 56 and 40. So I know I'm going to pull, and notice I brought down the plus sign, right? I am going to pull out an 8. Now the variable. Is there a variable on both of those numbers?
Mm-mm.
No, there's only a variable on 56. Since it's not on both, I can't take something out. Like if I have a basket of apples here and a basket of oranges, can I take an apple out of both?
No.
No, okay? They don't have anything in common, right?
Right.
So, I cannot take a variable out here. I can only take out a number. So now I draw my parentheses. And again, when I'm taking out a variable, I do what? What operation? Divide. So this time I'm dividing both of these by what?
8.
8.
7.
So 56 divided by 8 is
7.
7. Don't forget the
X.
x. Very good. Plus 40 divided by 8 is,
5.
what do y'all notice?
They are the same, it kind of.
The parentheses are the same, aren't they?
I guess.
Okay, now, here's where it gets a little mind-blowing.
It's already mine.
It's already just mine.
Now, let's say instead of these parentheses, it said x squared y plus 8y.
Where you
I'm
get
just saying,
that?
I said, let's just say,
Okay.
let's just say the parentheses aren't there, and I've got x squared y plus 8y. Notice, what did I do? I changed 7x plus 5 to y, didn't I?
Yeah.
What do both of these have in common?
I don't know.
A
Why?
A y. So just like I did up here, in each individual parentheses, couldn't I technically factor out what they have in common?
Yes.
I could pull out the y, couldn't I?
Yes.
Opening
Oh
up
my
a
gosh,
new-
it's A2 plus X.
Hang on,
Never mind.
hang on. So I divide by that y, right? Okay?
Yeah.
So I take a y out of y, they cancel, and I'm left with
X squared.
x squared. Plus, take a y out of y, I'm left with 8.
Hey, you were close.
Okay? So it is x squared plus 8 inside the parentheses.
Boom.
What was y again?
The 7x plus 5. So yeah.
What?
Wait.
Why are you doing that?
I'm so confused.
I'm so
The Y just stands for the first parenthesis.
The y just stands for those two parentheses that are the same.
Wow.
Okay?
Wowzers.
Now, you don't have to go through and do that y part. You just need to recognize that these two parentheses are exactly the same. Therefore, they're their own common factor. So what I can do is y'all, stop saying that I'm confused and I don't understand and actually pay attention and quit complaining. The more you complain, the more you're setting your own self up for failure because you're automatically assuming that you don't get it, as opposed to actually trying to understand. Now, these two right here, I let be y here, didn't I? Because that makes more sense to us, doesn't it?
Mm-hmm.
One letter does, as opposed to one whole parentheses with a bunch of stuff inside of it,
Mm-hmm.
right? I literally let y be that 7x plus 5, okay? Because then when I looked at it, I was like, oh, they both have a y in common. I'm going to pull that y out. These both have that parentheses in common, the 7x plus 5, so I'm going to pull it out. And it's going to open up a new parentheses just like it did here. What's left? If I no longer have 7x plus 5 here, what do I have?
X squared.
Plus, if I no longer have 7x plus 5 here, what do I have?
8.
Okay? Now, if that doesn't quite make sense, always replace those two parentheses that are the same with a different letter. And then it might make a little bit more sense. You just have to remember to replace the letter back at the end, like I did. You see, I went back and I said, well, what was y representing? The 7x plus 5, so I put it back. All right?
Oh, was that an X squared?
Yes.
Oh.
Now, to type an x squared into Schoology, all right? Because I did not make these multiple choice because that's too easy. Because then you could just go backwards. So, to type these into Schoology, you would type, so this answer you would put parentheses, 7x plus 5, close parentheses, open parentheses, x, and if you press Shift 6, okay,
At the same time.
on your, well, I mean, you would press Shift and then you would press 6. The number above the 6, because y'all know how to do an exclamation point, you press Shift 1,
Yeah.
right? Okay, the number above the 6 is a little up symbol like this,
Really?
okay? Yes.
Wow.
And then you would, so this is basically saying that the 2 you're about to type is going to be going up as a exponent. It won't actually go up, but it's there to represent that it's supposed to be an exponent. And then your plus